Hey everyone, welcome back. Ever wonder how AI models handle those super long texts, like a 2,000-word essay or a 32,000-token story? It's a huge challenge, but researchers are making breakthroughs. Today, we're diving into a game-changing architecture called SambaY that's redefining how AI processes long sequences. Let's break it down. So here's the problem. Traditional models like transformers struggle with long contexts. They get slow, lose track of details, and need extra positional encoding to know where words are in a sentence. But what if we could make this process faster and more accurate? That's where state space models, SSMs, come in. They're like a more efficient version of transformers, but they've had their own hurdles. Enter SambaY. This new architecture combines the best of two worlds, SSMs and hybrid designs. The key innovation: a simple but powerful tool called the Gated Memory Unit, GMU. Think of GMUs as traffic controllers for your model's memory. They decide what information to keep and when to use it, cutting down on unnecessary computations. Here's how it works. SambaY uses SSMs to handle the heavy lifting of sequence modeling, but replaces half of the attention layers, which are computationally expensive, with GMUs. This means the model can process long texts 10 times faster than previous methods, without sacrificing accuracy. And here's the kicker: it doesn't even need positional encoding anymore. That's a huge win, because it simplifies the model and saves resources. The researchers tested SambaY on tough reasoning tasks, like solving math problems or analyzing complex texts. The results: SambaY outperformed state-of-the-art models like 5.4 mini reasoning, even without using reinforcement learning. And with a 2,000 token prompt, it generated 32,000 tokens of text 10 times faster under the vLLM framework. What does this mean for the future? SambaY isn't just a tech upgrade, it's a step toward more efficient, scalable AI. Imagine chatbots that can handle lengthy conversations, or systems that analyze massive documents in real time. The team's open-sourced code also means others can build on this work, accelerating progress for everyone. But SambaY is just one piece of the puzzle. Let's zoom out. How do models like ChatGPT or Gemini keep getting better at understanding and generating text? It's not just about making them bigger. It's about smarter upgrades that make them faster, more efficient, and better at handling complex tasks. At the heart of this is something called scaling laws, a way researchers figure out how to improve models by adjusting factors like batch size, data volume, and training time. A 2024 study by SWW+24 showed that scaling these elements can unlock surprising performance boosts, almost like giving a model a bigger toolbox. But here's the twist: not all improvements come from making models larger. Some of the most exciting advances are tiny tweaks with massive impact. Take layer-condensed KV cache, a 2024 technique that optimizes how models store information during text generation. Think of it like a librarian organizing books. Instead of shoving every detail into a cluttered shelf, the model uses a smarter system to retrieve only what it needs. This makes inference faster and less resource-heavy. Then there's Scope, another 2024 innovation that compresses memory usage, letting models handle longer texts without slowing down. It's like upgrading from a backpack to a suitcase, same content, way more efficiency. But how do researchers know what works? They rely on benchmarks like MMLU-Pro 2024 and GPQA 2023, which test models on complex tasks from math problems to logical reasoning. These challenges push AI to solve problems that require real-world thinking, not just pattern recognition. And the results? Models are getting better at tasks that once seemed impossible, like solving equations step by step or analyzing nuanced text. Here's where it gets even cooler. Some of the biggest leaps come from rethinking how models process information. For example, researchers discovered that the order of operations in neural networks matters a lot. By rearranging steps like normalization and gating, think of them as the model's traffic controllers. They boosted performance for long texts by up to 50% in some cases. It's like tuning a car's engine. Small adjustments can make a world of difference. These advancements aren't just about faster code. They're about making AI more practical for real-world use. From handling lengthy documents to solving complex puzzles, the future of AI is about efficiency as much as power. And as researchers continue to refine these techniques, we're entering an era where AI can tackle problems that were once beyond its reach. So next time you see an AI model tackling a long task, remember, breakthroughs like SambaY are making it possible. Thanks for watching. If you want to explore the paper or code, check the description. Stay curious, and we'll see you in the next video.